Hi, welcome to Technical Education. My name is Abhishek and in this video I am going to discuss on Bode plot, which is a part of the control system. So if you are new in my channel, then please subscribe to my channel and press the bell icon for regular updates, because you will be getting this type of videos in my channel. So let's start with this topic. So first of all, you need to know what is Bode plot. So Bode plot is a plot of decibel values of magnitude and phase angle in open loop transfer function. So this is a magnitude g of j omega, h of j omega versus log of omega. Okay, so this is the definition of Bode plot. Now for solving Bode plot, you need to remember some points. So see, first point, for first order factor 1 plus ts plus minus of 1. Okay, so for that you have to, for calculating the cutoff frequency, CF means cutoff frequency. So if you want to calculate the cutoff frequency for first order factor, the formula is 1 by t, and the magnitude or slope is plus 20 dB by dcc. For poles it is minus 20 by dB by dcc, and for 0 it is plus 20 dB by dcc. So see, I am showing you the example. This is pole, this is one pole, s plus 5 in pole, and this is an example of zeros, as you guys can see. See, first we have to represent in time constant form. So after representing it time constant form, it will become, you will take 5 common and it will become 1 plus s by 5. So and the formula of calculating cutoff frequency is 1 by t. So t becomes 1 by 5. So omega cutoff frequency is 5. Okay. So which means you have to up to 5 it is 0 dB. The plot is moving 0 dB, and from 5 it will move in parallel with minus 20 dB by dcc. Okay, because slope is minus 20 dB by dcc for first order factor. Similarly, this is the example of zeros. You will take 5 common and you will find t, and from here you will find the cutoff frequency 5, same as poles. And here you have to move 0 dB, and then the slope becomes plus 20 dB by dcc, because this is a 0. For 0 minus 20 dB by dcc, plus 20 dB by dcc, and for poles minus 20 dB by dcc. Okay. So system gain. So see, so this is a question, you have to solve this. So this k, you can see this k is a system gain k. Okay, so f of s is equals to plus minus of k. It will be either plus or minus. So if you put j omega in place of s, it will, so after, and the angle will become 0 degree for positive k. This is a very important point which you have to remember. 0 degree for positive k and minus of 180 degree for negative k. And the magnitude or slope for this system gain k is, formula is 20 log of fj omega. So and mod of fj omega is k. So you have to calculate using, suppose for example, suppose k is here, consider 5.2. So what you have to do, you have to write for calculating 20 log of 5.2. Okay, so the value will come 14.32, which is 14 approximately. So here it is starting from 0 dB. If the gain is 14, then you have to start calculating from 14. So it will start from here, it will shift to 14. Okay, So this is the main role of system gain. Now next comes to S plus minus of n. So S minus of n is n number of poles located at origin if S minus to the power minus of n. Okay. And if it is S to the power n, so n number of zeros located at origin. So you have to calculate mod value. So Js is equals to S plus minus of n mod to the power. So G of j omega is j omega plus minus of n. So mod, it will become omega plus minus of n. And for calculating it, you will get this value, because you have to put 20 log of mod gj omega. So in place of gj omega, we have to put this value. Okay. See. So after putting, you will get this. So if it is positive, then it will move. If the dB value is slope is positive, then it will move toward the upward side, and if it is negative, then you will move from downward side. As you guys say, plus m minus m, plus 20 dB by dcc minus. See, for example, if s is equal to s square, so as the power is 2, so here it will come 40 log omega. If it is the power is 3, then it will come 60 log omega, like that. Next, coming to the numerical portion. See, this is the numerical which I am going to solve. Okay, so gs of 3 s plus 1 s plus 700 s square plus 8s plus 400. So first step is first represent it in time constant form. So you have to represent in 1 plus of s. See, 1 plus s already in the time constant form. You have to change 7 plus 700 and this second order system. So you will take 700 common here and it will become 1 plus s by 700. Similarly, you have to take common 400. Okay, so if you take 400 common, you will get 1 plus 18s by 400 plus s square by 400. So, and after simplifying, you will get this 5.2, 1 plus s, 1 plus 700 by 700 s by 700 s square, and 1 plus 18s by 400 plus s square by 400. Okay, and this 5 by 2 is the system gain, as I told you. Okay, see, again you have to put s is equals to j omega in this question, and you have to simplify like this. And the third step is very important, VVI, which you have to do is you have to make the column, 3 columns. One is for factor, another is for cutoff frequency, and the another one is for magnitude or slope. So first I am starting with the constant k. Okay, so this is the constant k. So in place of factor, you will write first the constant of k, which is 5.4, and you have to calculate the formula plus 20 log k. So in place of k, you have to put 5.2. So what you will get? You will get 14 dB, and there is no cutoff frequency for the system gain. Similarly, for this one, 1 by j omega square. This is situated in pole. Okay, so remember, if it is situated, I told you that s plus minus of n. So if it is situated in pole and the power is square, so it will become minus 40 dB by dcc, and there is no cutoff frequency. Now comes to 1 plus j omega. Okay, so 1 plus j omega. So you have to find the cutoff frequency for this, because this is a first order system. So formula of cutoff frequency is omega is equals to 1 by t, and here t is 1. So you will get the cutoff frequency 1, and here, and for this, as it is situated in 0, so the magnitude is plus 20 dB by dcc. Next comes to this, because you have to first find the cutoff frequency for the second order system, and the formula for finding the cutoff frequency for the second order system is omega of Cf is equals to omega of n is equals to root under of 400, this 400. So root under of 400 becomes 20, and as it is situated in the pole, so here it is minus 40 dB by DCC. If it is situated in 0, then it will become plus 40 dB by DCC. But minus 40 dB by DCC is due to situation, it is located in pole. And next comes to this 1 by j omega 700. So this you will similarly you have to find like for the first order system, and you will get 700. Now one question arises in your mind, that why I am taking first this, then this, and then this and this. Why I am not taking the zeros first and the poles last, or poles first, zeros last? See, you have to cut off, you have to arrange according to the cutoff frequency, because basically you have to plot in similar graph paper. So when you are plotting in similar graph paper, so you have to check, you have to arrange according to the serially according to the cutoff frequency, because see, 1 comes first, then you are then 20, and then 700. So you can't write 700 first, then 1, then 20. Okay, because so you have to check. See, here you are getting here the cutoff frequency value is 1, so you are taking it first, then you are taking this one, because cutoff frequency for this is 20. So after 1 you will write 20, so you will write this, and then you will write, and the cutoff frequency is 700 for this. So this is serially wise. Okay, you have to write it in serially wise. And for k and this j omega square, there is no cutoff frequency. So this is the table. Now I am going to plot the Bode plot. So see, so first you have to draw the axis. See, follow this, the steps which I am doing right now. See. Okay, so this is the axis, this is for omega, and this is dB by DCC magnitude. See, here I am going to write 0 dB, this is plus 20 dB, this is plus 40 dB, and this is plus 60. Like this you have to write, and this is minus 20 dB, minus 40 dB, and this will become minus of 60 dB. And in similar graph paper it is like this, 100, it is different from the normal graph. Okay, so 1000 means this one 0.1, 0.2, 0.3, like this you will receive 1. Then here you will similar graph paper basically like this. See, so this is 1, this is 100, so means here you this is 0.1, 2, 3, 0.2, 0.3, 0.4, like this you will reach 1, and after 1 you will see 1, 2, 3, 4, 5, no sorry, after 1 you will see 10, 20, 30, 40, 50, like 100. And similarly after 100 you will get 200, 300, 400, 500, 600, like 1000. So this is type of the similar graph paper. So we have to plot according to this value. See, well, now you have to do what? See, minus 40 dB by DCC. So there is no cutoff frequency for this. So you have to move minus 40 dB by DCC till you reach the cutoff frequency 1. Okay, cutoff frequency 1, and after you are getting 1, you have to move minus 20 dB by DCC. So how it is become? See, this is, so you are moving minus 40 dB by DCC, this is 1, suppose you are moving minus 40 dB by DCC till 1. So you have to move again 20 dB by DCC. So what you have to do? You have to follow this 20 again. If it is increasing, then you have to write like this. DCC. So minus 40 dB by DCC till 1, and from 1 you have to move minus 20 dB by, this is you, because minus 40 plus 20 becomes minus of 20 dB by DCC. Okay, so from 1 to 20 you are moving minus 20 dB by DCC. From 20 you have to move 60 dB by DCC till 700, because minus 20 minus of 40 becomes minus of 60. Okay, and similarly after you are getting 700 you have to move minus from 700 you have to move minus 40 dB by DCC, because minus 60 plus 20 it will become minus 40 dB by DCC. You have to calculate gain margin, phase margin, gain crossover frequency and phase crossover frequency. So I will be showing you in my next video. So I hope you understand this Bode plot. Okay, so and if you want to ask me related to this, or if you have any doubt, or if you want to make any changes regarding this video and all, so you can comment me in the comment section given below, or you can mail me in my following mail ID. Okay, so I am ending this video now, and don't forget to subscribe my channel. So bye, take care.